Thank you very much indeed. It's an honour to be here. I'm very grateful to have been invited. Welcome to Refactoring Superpowers. I want to set the scene, picture the scene. You have been working on some software, maybe you're familiar with it, maybe you're not, and you're asked to implement this wonderful new feature. You know it's something that the users are really keen to see. It's going to make a big difference to their lives. So you should be happy, right? It's going to be a really good thing to do. But you know that the software wasn't designed for the capability that you need. And this makes things hard. You think that you probably could get away with pulling the software apart and putting it back together again, and yeah, maybe the test will still pass. But you could be working on it for days. You could break it, you could get it compiling, but still have a huge amount of debugging to do. So you're not so excited. And you know from past experience that the best might happen if you pull the software apart is that it takes some time and you have a load of debugging to do. But the worst that might happen is that you get so bogged down that you never complete it, and the time that you've just spent is lost. The deadlines are getting closer and you haven't made any progress. Not a nice place to be in. My talk today is showing a different way of working in these situations. And it's a way that I think many people are not so familiar with how powerful it is, because it seems such a simple approach to take. And that's what I want to share with you today. And that's what I mean by refactoring superpowers. Just briefly about me, my main background was chemistry. That's what I studied at university. And I was employed for 30 years in the field of chemistry, and for more than 20 of those in C++. And I had a lot of fun working on 3D crystal structure visualization software. In recent years, my interest has been very specifically on testing, mainly through having got involved in the approval tests framework, working on that open source and giving conference talks about that. And so I had a lot of practice working on legacy code and testing and refactoring. If you want to get in touch with me, you're very welcome to. My Twitter handle is on the bottom of most of the slides as well. So I want to just to sort of try and set the scene a bit more. I can't tell you everything about refactoring in even a talk as long as this. So I'm setting out to inspire you to experiment, to explore, to learn, to try these things out. And when you find a new capability, practice with it, try it out on some code that doesn't matter, something quick, and get into the pattern, and you'll find these will help you a lot. The themes are broadly around the tactics for refactoring, the kind of how to string refactorings together. A lot about maximizing the help you get from your IDE, your integrated development environment. And I guess I should say at this point that everything I talk about is based on using a development environment that has knowledge and power built into it about the language that you're programming in. So this isn't about Notepad or anything like that. This is about using tools that are designed to help you, and other people have spent their career working on to help you out with your career. And I'll talk a lot about making changes safely. But before I press on, I just want to pay tribute to Emily's talk on Wednesday, to Wednesday's keynote, and to point out one of her lovely Q&A Mentimeter questions. And the question was, do you see a need to get better at any of these technical practices? And the one I've ringed round is reducing technical debt safely via refactoring. And I was very heartened to see that that was the most voted for thing there. So I believe that there's a lot to be gained from learning refactoring techniques, and it was really, really exciting to see that lots of other people thought so as well. So for those who haven't seen refactoring before, what is it? Well, it's a way of restructuring code as opposed to the rewriting or pulling apart that I mentioned earlier. It's about keeping the behaviour the same. And it's very much not about fixing bugs. Often the motivation for refactoring will be to modify the code to make it possible to fix a bug, but they're separate stages of work. And so especially, it also doesn't mean adding new features. That's also a separate phase of work. Broadly speaking, the process is you see a smell in your code, you see something that you don't like, maybe something that's hard to maintain, something that you don't understand, something that doesn't allow you to do something with the code that you need to do, or something that's just too hard to do what you need to do. And so you make a safe change, and then you test the code. And I'll talk a bit more later on about what to do if you don't yet have tests, if you don't yet have automated tests. Sometimes, though, at this first stage, if you're working on code that doesn't have any automated tests, it's fine when you get started to be testing the code manually. It's you should be knowing you should be able to run the code that you're working on anyway and know what the expected behaviour is. If you don't, then you need to get a domain expert to help you. So if you don't have automated tests and you're starting off on some legacy code, that's fine. Take the time to add the tests up front, and in the meantime, test it manually. And that time that you spend adding automated tests will pay back for itself many times over. So your test passed, and then you commit, and then you repeat until done. So you might be wondering, there is a number of implicit questions in that slide. What smells? What do we mean by smells? So smell is a term that's used by people who talk about refactoring for a thing that you don't quite like, a thing that smells odd, a thing that you want to improve. And I can only scratch the surface of what kinds of smells you might look out for in this talk. So this isn't a talk about teaching you all about refactoring smells. It's about letting you know that vocabulary, refactoring smells. So if you're stuck on some code and you don't know what to do, you can Google for that and find options. What about safe changes? What is a safe change? That I'll talk about more. And when am I done? That too I'll talk about more. It's really easy to get bogged down and spend ages refactoring the code and not actually make the change you need to make. So let's talk about safety for a minute. Where does this safety come from? Well, the first place it comes from is your IDE. It will have things like syntax highlighting. It will tell you, it will highlight errors when there are errors. It will run the compiler for you. You'll get feedback if your code doesn't compile. But most amazingly, it will have tools built into it to allow you to instruct it to do your edits for you. And those are of which the refactoring tools are a large part of that. And the people who created your IDE have spent a lot of time understanding for each programming language that the IDE supports what things they can do automatically and how they can analyse your code and work out how to make the change. So not only can the IDE make those changes much more quickly than you can, they can do it much more safely because it's building on other people's research and work. Your tests, of course, you need to be running your tests all the time. And that means your tests need to be fast, or it means you need to be able to run the subset of tests that are relevant to the code that you're changing. And version control. Now, it's possible that this next thing I'm going to say may feel quite controversial to some of you, but bear with me for a minute. As you're refactoring, you need to be committing each small change to your version control system every time it works and the tests pass. Now, if like me, you've worked on large systems with decades worth of version control history, you might feel a bit nervous about large numbers of tiny commits that say extract method, rename thing, inline this, extract that, move this. Because big part of the power of version control is understanding the intention of changes. And when you're making tiny changes during refactoring, often committing once every 2 minutes, every 1 minute, maybe even every 30 seconds as you get into your stride, it's not feasible to put long descriptions in at every stage. You're really looking at the detail. And I want to ask you to suspend your disbelief with this and try it out. So I'm not saying anything about once you've finished the refactoring, you have to push all of the individual changes. That's a policy thing for your organization. Maybe for the size of the code base that you have, maybe the request is that you squish the changes afterwards. If you can commit the individual changes, that's fantastic, because it will make code review a lot easier, and because people will be able to review each individual step. And also, in the unlikely event that you do introduce a problem that you didn't discover at the time, Git bisect, the sort of navigate through the history. My code worked here, it didn't work here, and then the version control bisects through, and you test each step, and eventually it narrows down to say, this is the commit that made the change. And I don't know about you, but many times in my career, once we were using version control systems that supported bisect, it really, really saved me from very long debugging sessions. And I didn't even know where to look. And if bisect takes you to a change that changes hundreds or thousands of lines, well, it's narrowed it down a bit. And maybe if the developer who made that change is still there, you can move forwards. But the smaller the changes, the more useful that history is. So digging down a little bit, what I'm really talking about is what people call micro refactoring, so making small changes. So you get your IDE to make a tiny change, you review the change and you see if you like it. And I'll talk a bit more about what I mean by liking it shortly. Then you run the tests, and then you commit the code, and then you carry on, and you keep going until your feature is done. But there's a bit more to say about that. What do we mean by review? Well, it might mean you've extracted a method, and the IDE has chosen the names of the parameters, and it's got them from your original code. And you think, I don't like those names. That's confusing. If I accept this change, that name will be in the old code and in the parameters of the new method, and I'll have to change it and rename in both places. So you might revert the change and then do a smaller step. So that reviewing is valuable. And then you run the tests. And if the tests fail, you revert the change. And if the tests pass, you commit and you carry on. So what I'm really trying to stress is let the IDE make the change. And if there's a problem, don't try and fix it, unless it's an auto thing like make a method public or something like that. But broadly, if it's produced broken code, revert and try something different. Try different options in the tool, try a different refactoring. And I love this summary from this statement from Kent Beck. You can see it's 9 years old, nearly 9 years old. For each desired change, make the change easy. Warning, this may be hard, and then make the easy change. And that theme you'll see throughout this talk. So I'll talk more about this later, but essentially what started off as a talk about refactoring became a talk about flow. And that means your flow when you're working. If you don't know the word, you might think of it as being in the zone, that state where you're relaxed, and each change that you make, you know what to do, and you can do it quickly and in a streamlined way. You're not having to think, I need to make this change, and I need to write down a list of the 10 manual steps I need to do, plus I need to remember what I intended my next step to be, because I'll have forgotten by the time I've made the 10 individual steps. No talk on refactoring would be complete without mentioning this amazing book by Martin Fowler. I've got the first edition, but for this talk, preparing for this talk, I bought the online version of the second edition, which was released a couple of years ago. Alongside the book, there's a website which is open to all called refactoring.com, and it has this catalogue of refactorings and with the tags down the left-hand side. So I've said, show me refactoring, so patterns of small change to allow me to move features. So maybe move a field to a different class, move a function, move statements up and down, all sorts of things like that. So I find this is a useful source of inspiration. If you've bought the online version of the book, or I think the paper version gives you access to the web version as well, then all of the content in the book, printed book, plus some extra content is available in the Refactoring web edition. And there are links from the catalogue, which is free and open, to the web edition. And so I find those two websites together are really powerful. Okay, so for this talk, I wanted to have something concrete to talk about. It's quite hard inventing code purely for the sake of demonstrating real-world refactorings. And I have been enjoying Sudoku recently, occasionally getting slightly hooked on it on my iPad and then uninstalling it for a while and then coming back to it. And so I was Googling for example code to work on and found this video. It's a JetBrains webinar from something like 4 years ago called Refactoring a 1,000-Line Method into Cleaner Code by Zoran Horvat. And so I watched this video and I was intrigued by how he worked. And so he was depending on the compiler and his knowledge of the code as he made changes. So he would break code and move it around and get it working again. And he ended up with a really nice design at the end of it. He didn't get through it all in an hour. He didn't do all the work in an hour. He'd kind of compressed it together and sort of fast forward through stages. So it was interesting to see how much he achieved. But I was interested to know if I could find ways through the code that kept it building at all points. So if you haven't seen Sudoku before, here's a brief animation that shows how it works for context, though the details don't need to be memorized for the rest of the talk. So it's a puzzle. You have a 9x9 grid, 9 cells by 9 cells, so 81 slots. And you get given some clues to start with. Some numbers are filled in. And your task is to fill in the missing numbers according to the rules. And the rules are that in each 3x3 grid, which contained within the darker lines, each digit can only appear once. So we've only allowed 1 5 in that box, so we can shade out the rest of them. We're only allowed 1 5 in that section, and so on. And there's the last 5. So that's the first rule. The next rule is that each number can only appear once in each row. And so if we look down the rows, carrying on looking at the 5s, we can shade out and rule out everything in the 4 rows where there's a 5. And of course, the same applies to the columns. So we can shade out everything in a column that has a 5. And then the last thing is you can only have one number in each cell. So any cell that's already got a number, we can rule out. So in the top row, there can only, in this box, there's only one place that can have a 5. And that means there can't be a 5 in that row, and that means there must be a 5 there, and that rules out that column. And then we can pencil in the and say these are the remaining positions for the 5s. So that's the idea behind Sudoku. So the code, the GitHub URL is here, and Zoran's description in the README is that it's a coding practice, a kata, demonstrating an awfully long method, and that's his word, awfully long method. And the job is to try to refactor it, a 1,000-line long method. And it's in C#. Now, I mentioned earlier that I identify as a C++ programmer, and I've heard good things about C#, and I was interested to see how I would get on with this. And a spoiler is, it's a lot of fun. I really enjoyed it. I learned a lot. And I could never have achieved what I did in the code in that space of time if I'd had to learn the language from scratch. But by starting with existing code and then using all the capabilities built into the IDE, I was able to get really a long way. So step number one is to add tests if you don't have them, and this code didn't. And so I've got a short video showing how I modified the code to add tests. So what we've got here is the original program, it's main, and so it's unfamiliar code. The first thing to do is to run it. And you don't need to read all of this, but I'm scrolling up the console output and there's thousands of lines of output. And what it's printing out, it first creates a full board with all 81 digits in it. Then it removes some digits to give you the starting point, like I just showed in the animation. And then it works through trying to solve the puzzle. So it's all three stages of Sudoku built in. And it's really good that we've got that console output. That's really going to help us out with writing the tests. If it was silent and just wrote out the answer, we'd have no confidence that we're keeping the same behaviour. So I'm calling the test should do the same thing twice. And I need to capture the console output. And so Google told me that the way that you do that in C# is console.setOut. And then the IDE told me I needed to pass something in to capture it. And so I wrote some code that didn't compile and then did Option and Enter. And I got a menu that created the thing that I needed to type. And a little bit of searching told me that it was a string writer that I needed. So now we're ready to call the code that we want to test. And I should say at this point, we'd already done the work of setting up the test framework and adding support for using NuGet to add the C# implementation of approval tests. And you'll see approval tests in action in a moment. So let's go ahead and run the test. So approval tests allow you to save the output from some existing code and capture that as the right answer. And to be checked against in future runs. So the first time you run an approval test, a diffing tool pops up, and on the left is the received, what was written out by this run of the test. And of course, it's never been run before, it doesn't know the right answer. So I copy the text over to the approved side and save it and quit the diffing tool. And I expect that when I run the test again, it will pass. But it didn't, and I get different results. So that suggests that maybe there's some randomization going on here. So I need to look at the code. Maybe it's using date and time. Maybe it's got some random call. So I'm searching back for random until I see any clues to what's going on. Okay, so it's rng.next. So what's that rng? Okay, it's a random object. So I'm using a refactoring introduce parameter and saying promote that object to be something that gets passed in. And you can see on line 16, it's updated my code and put in a default constructed random. And I can give it a seed. I can say every time you run this test, start the random number generator at a known point. And now we'll get different output, but this time when we approve it, we expect that we will see the same output the next time. That's the hope. Let's see what happens. Hooray. So we have a passing test. That's good. But how good is it? I want to see the code coverage. I want to see how well it has, how much of our play method has been covered. And the answer is it's 90%. So I don't like the risk of potentially breaking 1 in 10 of the lines. And so I want to add a for loop here. And I'm doing that by selecting the line and then saying quick fix surround with a for loop. You see all these different things I can surround the code with. So I didn't even have to write a for loop and know how to do that. It did it for me. And then I must remember to update the code to use the new value. And I'm always thinking when I run the tests, what do I expect? And I've changed the output, so I'm expecting the test to fail by popping up the differencing tool. So it's not just, is it going to pass or fail? It's what is the behaviour that I'm expecting. Because if I expected it to fail and went one way and it passed in a different way, that's useful information. So I've approved that new output, and now we have a stable test, and you can see on the right-hand side that we're up to 100% coverage. So I'm pretty pleased with that. That was a good few minutes. So a quick summary of the code that we changed was we started off with the program class that had a play method that took no parameters, and it was not public, and now it's public, and it takes a random number generator. If you had a commitment to maintain the previous interface, then of course you could add an overload and you could get the IDE to add the overload. But at this point, I know that nobody else is using the code, so I'm fine changing the interface. Now, when I was preparing this talk at this point, I spent, I don't know how many hours, days and days, playing with different ways of refactoring this code, pulling it apart, step by step. And I got really quite bogged down. And at some point, I was talking to somebody about the talk. Someone I met through one of Emily's ensemble programming sessions. So the joy of sharing work online is getting to meet other people and having new people to share ideas with. And he said, yeah, you need to have a target. You need to have something to aim for. You can't just enter a refactoring endlessly. So avoid the bottomless refactoring pit. Know the purpose of your change. Know what you're working towards. It might be solving a bug. It might be adding a feature. So for this talk, I decided that my goal would be to see if I could get this code to solve puzzles set by others, perhaps by my iPad or perhaps by a website. So that's what I'm aiming for. Warning, don't be tempted to read the code in this next slide. So to give you a sense of the shape of the code, here's the first bit of a screenshot. And you can see it's already getting quite nested. And each of these is 100 lines long. So we've got 1,004 lines of code. Now, if I wanted to internalize that and understand it, it would take me a long time. And I'm not sure how, I don't think I would succeed, basically. So what do you do with a long method, with long code? You start by extracting a method, separating it out, and then you've got two smaller things to look at. And obviously you can repeat that. But in this particular code, thanks to the C# regions that the author put in, I can see the blocks, I can see the structure of the code. So line 13 and following creates the full board. Line 195 and following removes some cells, it makes them empty. And then the remainder, so over 700 lines of code, 750 lines of code, is solving it. And since my task is to use the solving code, that's what I'm going to refactor. So I will get I've selected, collapsed all the code and said refactor. And the only option for refactor this is extract. And I'll make it a method in this class. So I'm reviewing the parameters that it said need to be passed in. Everything else is variables used inside that code, which I don't need, so I'll leave them not returned. So I've reviewed it, I'm happy, I'll call it solve board, hit return, and this is not speeded up, this refactoring. That's how fast C# IDEs can extract large amounts of code. So I've got my new solve board call, and so what that's already done for me is narrowed down from that 1,000 lines to tell me that the only variables I need to know about to feed into solving the board are state board and final state. I've got no idea what they are, but it saved me from looking at any of that earlier code. And if I want to understand the inputs to solve board, I only have to look at those three variables and trace back how they're used. I could run the test in a debugger and put a breakpoint in at the start of solve board and inspect those values and see what was passed in. So that's moved me a long way forwards already. You won't always have these regions helpfully named, but there'll be the structure of the code, the for loops, the whiles, and often people put in comments in long methods, dividing them up. Okay, so there's a quick reminder that we used refactor this and chose extract method. And so we've gone from starting off with a program that had play method to introducing initially a private solved board method and the parameters there. Okay, but I don't like those three arguments. I don't exactly know what they are yet, but they're probably related. So I'm going to use something called transform parameters, which I've only seen in C# IDEs and not C++ IDEs. I select the method and say transform, and I say I want to keep random as something separate, but I want my int, my char off the bottom, the last int. I'll create a new, please create a new class for me, public fields for now for simplicity, and let's call it grid. And what I now end up with is where before this solve board took 4 things, the new solve board takes 2 things, and the grid has got this public data. And I found that visualization of the change as I went along was quite helpful. Often I would have that in my mind. I wouldn't actually run some tool to create UML diagrams for me. But so now, by inspecting what was going on with this board, this character array, looking where it was modified in the code, what I found was that all it was doing was used in the writing out of the results, if you remember all the screeds of console output that we saw. And it turns out that this board, this character array, is duplicated data. It's a second copy of our board. The master copy is, the main copy is the ints in the array. And whenever you have duplicated data, a great way to simplify your code is to not store both copies and risk getting them out of sync, but to create a mechanism for generating them on the fly when you need them. And so that's what I did. I've created this convert to string method, and I wrote this incrementally with unit tests as I went. So as I refactor the code, I'm starting to add tests for the bits that I break out. And so what I then ended up with was a grid that no longer had anything to do with characters. It just had final state and state, and I got my grid stringifier class. So that's pretty good progress for just a small series of changes. Now remember this quote, for each desired change, make the change easy, then make the easy change. Well, we're there now. We're pretty close. So I will always write my test first, partly so that I can see what the code looks like that I'm generating, that I make sure that it's usable, but also so that I can get the IDE to do the work for me. So I've got my input string, which is 81 digits that I got from some website, and then I fed that into another website and got the solution. And the other website told me it's a unique solution. So I want to say grid.solve, so it's a static method, pass in the input and get back a grid object with the solved answer in, the solution in, and then to string and do the test. And all I needed to do by this point to implement this was, if you look at the top first, I chose to write a grid constructor that took a string as input. As a first step, I just put in an assert on the length. In practice, later on, I would add a test that's sensible error message was issued. But for the first stage, an assert will do. And then a nice select, input.select, get each of the individual characters as a number, feed them into a list, convert it to an array, and that is my state field, as in C# people call it, data member in C++. And it turns out that final state is not actually needed when there's a unique solution. It turns out that what the code does is the boards that it generates are not, it doesn't do the work to make a unique solution. And so if it's solving it and it finds there's more than one solution, it picks from the initial state. But if I'm feeding it something with a unique solution, I don't need to, it ignores final state, it doesn't use it. And then I can write my grid.solve, my static method, create a grid with my input, program.solveboard is public, and return the solution, and my tests pass. So I have to admit, by the time I'd spent so long experimenting with the code and understanding it, that when I set out to start from scratch and implement this, finding a solution, I wasn't expecting it to come out so quickly, so easily. I was really pleased with that. So was it worth it? Was it worth doing all of those small steps bit by bit and committing at each point? Absolutely, it's worth it. People sometimes think they can make a change by hand and it will be quicker, and sometimes they're lucky. But by making these incremental changes at every single point, I've committed the code and the code is a little bit better. So often you'll find that approach is quicker because you're not spending time debugging, not spending time fixing compiler errors. But even if it doesn't, it very rarely takes more time. Even if it doesn't take less time, at each stage I've committed to version control and I've made a slight improvement to the program. So if something happens and I have to put this work down, other people can pick it up. And if I come back and pick it up, I've got the version control history that tells me where I got to. Whereas if I'd shelved hundreds of lines of changes and had to come back and pick it up, I might lose the shelf and I certainly wouldn't remember where I'd got to. So that's the power of making small changes incrementally. Now, for the remainder of the talk, I'm going to tell you about some more options for refactoring in modern IDEs. And I want to try and give you some pointers and some clues so that you can start experimenting on your own, because it's easy for things to not quite work as you expect. Again, it's just scratching the surface. It's intended to encourage you to, or enthuse you to try things out. So the first thing to tell you about refactoring in an IDE is where your cursor is critical. So many times I've seen people go to rename a variable or extract a variable or change something from public to private, and they don't get the options that they expect. And so if you go to do a refactoring and you find that the option you want is disabled or not in the menu, move the cursor, select somewhere else. If you want to auto-fix an error, make sure you put the cursor exactly in the characters of code that are highlighted in red and perhaps underlined, because that's the point when you'll be able to say auto-fix the code. But then once you've got the cursor in the right place, you have options like you'll probably have a refactoring menu in the main window. Or if the refactoring comes from an extension, you might have to go into extensions and then resharper and then refactoring. You can right-click in the code and a refactoring menu will pop up, or you can memorize the keyboard shortcut for refactor this. And that's my favorite one, because it will only show you options that are valid, but often it will show you extra options that were hidden away in the submenus that you weren't aware of. And then not quite refactorings, but similar kind of things. Quick fix, this variable was unused, delete it, that kind of thing, and generate code. I want to be able to write a equality test, so I can test if two instances are the same, generate in normal form the code to do that. So let's look at generating. I'm working on a class called game. And I've right-clicked on the class and said generate, and I've said generate me equality members. So the methods related to equality. And this is the code that it's generated. You see the green bar, the IDE is telling me this is code that's changed. So it's generated an equals method that takes the same type, another one that takes an object and that's override, and some get hash code thing, it's also an override, and I'm getting some warnings about it. And that took a second to generate that code. And even if I was an expert in the language, I wouldn't want to be having to think about all of that and get it right. And as a novice in the language, that's amazing. There's also quick fix that I've mentioned. So listen out to the warnings that you get from your IDE. So I'm partway through a refactoring. I've added a parameter. My original parameter line 1 is no longer needed. And it's warning me by greying it out. And if I hover over it, it will say parameter line 1 is never used. So previously, what I would have done is edit the function, remove the parameter, compile the code, and fix everything. And yeah, kind of tedious. But it turns out that you can, when you get a warning like this, if it's something that the IDE can fix, it will offer to do the fix, and it's telling me it's going to update all the usages as well. Wonderful. So every time I can state my intention, remove this thing, rather than decide to do something and then do it manually, is time that I'm still focusing at a higher level on the task I'm doing rather than the nitty-gritty mechanics. I mentioned in the video earlier, this is a different generation of the code, but the same principle. I wanted to write program dot whatever the name of my solving method was. This time I put the solver on the program code rather than the grid. They're all perfectly valid. But then the IDE says, do you want to create a method called that? And it generates it, and it knows the missing information that it needs to finish off the method. And it pre-populates it with useful initial defaults where it can. So this is how I learned that there was something called an IEnumerable of char in C#. But in fact, I changed this to string, but that was a useful thing to learn. So you hit tab or return and go through fill in each of the things that it wants. So what I've showed you so far is from my IDE, the IDEs that I am paying for licenses for. And of course, everyone's situation differs. You'll be working on different platforms, different languages, different IDEs. So I can't show you everything, obviously, even of my own scope, yet alone yours. But seeing these capabilities, I really hope, will prompt you to see what you can do in your tools and your language. And I'm afraid I have a slightly sad spoiler alert for C++ developers, that some of the capabilities that I've shown you, like the reshaping, transforming the parameters, they seem to be common in C# IDEs, and I've not found them in any C++ IDEs. And it's a much harder problem to solve in C++. But that's okay, because it's still a useful thing to do. That just means that if the tool doesn't do it for you, then you go to the refactoring book and you see a description of how to do it, tiny step at a time, and you make yourself a cup of tea and crack on with it. Part of that building these things into the muscle memory and streamlining them is, for these things that you're going to do so often, practicing the keyboard shortcuts. And I've spent nearly 2 years or so on a Mac now, so I'm used to Mac shortcuts. And these defaults, so Shift F6 to rename, Command F6 to change the signature, are consistent across all of the JetBrains IDEs. And so they were in my muscle memory. I was really happy with that. It was a good investment of time. And then for this talk, I moved to a PC and Visual Studio. And it had a completely different set of keyboard shortcuts. And I was somewhat glum about this because I'd seen this style of keyboard shortcut where you do Control and then a character, and then you type a second character. So Control R and then D to do a safe delete, Control R and then P to extract a parameter. But over time, I found that they really grew on me because they were much more memorable. There was a sort of aide memoire to them. You can see that rename ends in R, safe delete in D. The only one that doesn't immediately make sense is move, but at least O is in the word move, so it's not that hard. Whereas on the left-hand side, the only ones that obviously relate to, so V for variable, F for field, P for parameter. But you've still got to remember that those two, the Alt or Opt and Command key beforehand. And the other shortcuts are different from that, and they're function keys and things like that. So I've really grown to like these two, sort of two character, I think they might be chords, but control something and then either another character or sometimes control and another character. I found that they were much easier to remember. Unfortunately, by using multiple different IDEs during this talk, I've completely broken my muscle memory for the shortcuts on the left-hand side, the Mac ones. So I suspect after this talk, I'm going to be setting all of my IDEs to use the Visual Studio style shortcuts. I'm going to talk a little bit now about things that you can do in refactoring methods and functions. Because in the abstract for this talk, I talked about stringing together short refactorings to make more powerful changes. And so I want, as an example, to show you the results of some small changes in methods and functions, again, to try and prompt you to see what you can do with other refactorings as well. So here's a diff after using introduce parameter. And the way I ran this was I selected game.currentGrid and said extract that as a parameter, and then it put in the sensible default name of current grid, matching the naming convention for the code, and created that for me, updated the code in the method, and updated calling code. It's really lovely. As an aside, if this, so there's kind of a clue here. There's a smell. If you have game.board.row.column.cell, and you see that pattern in methods, that's a clue that you want to change the interface to not pass in the big monster parent object, but something smaller and reduce the scope of the method. And what these IDEs do, if you select something where there are multiple, a.b.c, it will pop up and say, which do you want to make the new parameter, a.b or a.b.c? It's really lovely, things that I never even thought an IDE might provide, and it just does. And then having made that previous change, the IDE then told me that I'd got an unused parameter, that game wasn't used. And so then I could say remove unused parameter. So small changes strung together. Change signature is similar to the transform parameters that I showed in the video earlier, but here you can reorder existing parameters. I might decide that I want final state to be next to state. So I might select final state and click on the arrow to move it up. And transform parameters I showed you earlier, so I won't talk through it, except to mention that it can also return tuples rather than classes as well. So it gives you good choices. And I just find it amazing the amount of work that's gone into these tools to save developers time. I think it's, really, really powerful. So there's a summary of the common abilities that you get for refactoring methods and functions. And as I mentioned earlier, the temptation is really to keep on moving code around, keep improving names. So improving the name of something that's unclear is a really valuable thing to do. And at some point, you'll get into diminishing returns, and dividing up and moving stuff around isn't making any difference. And you'll have to bite the bullet and start adding abstractions. So when you're adding abstractions, if you've got concepts in the domain, the area you're working in. So the Sudoku code, we've got concepts like a row, a column, a grid, a digit, or a cell that contains a digit. Those concepts, they're all there in the code. They're just not visible in the code because all of the storage is ints and chars. That's called primitive obsession, that smell. So examples of smells might be classes with lots of methods where I want to divide the code up. And a useful strategy is to move things that are related closer together and things that are unrelated farther apart. So let's look at the next few slides show steps that you can use to do that. So here I have a long method, and inside it's got lots of different calculations, and it's got 3 integers called thing1, thing2, and thing3, and they don't show up in the UML. And so I've selected each of those integers and said extract field, or it may be called introduce field. And what's happened is that the code has been changed so that I have got these 3 new fields, these 3 new data members. The key tells me that they are private and not static. And that's because my method was not static, so the data that's created is not static. If the code that I was extracting was a static method, then the new fields that were created would be static. So I can start that extracting data into fields, then makes dividing methods up to be simpler because you're not having to pass values in and out. And so this can be a nice incremental step on the way to dividing up code. So I decided that I wanted to keep thing1 and thing2, but I didn't want them to be, I didn't want to just make them public and use them elsewhere. So rather than making them public, I said encapsulate them. And for thing1, I said encapsulate it as an auto property, and that's a C# thing where it generates the code for you effectively. And for thing2, I said, actually, no, I want a getter and a setter, but auto generate those for now, and I'll keep the field as it was. So another nice incremental step. And then as time goes on, I come to something else, which it's got different concepts in this class. So I've got concept 1, whatever that is. It's got a data member, a field, and a function. And I can extract class, and it's this amazing thing that I can click on one of these things and extract it and select the related things, give it a new class or an existing class, and it pulls it out. So in just 2 steps, I was able to extract concept 1 and concept 1 function to a new class concept, and the same for concept 1, and the same for concept 2, and look at what I end up with afterwards. So my extract class afterwards, I've got a read-only field concept 1 that's accessible with this property. I'm not quite sure of the jargon, but I can refer to .concept1 with a capital C in my code. It's amazing. The amount of time I've spent in the past dividing code up by hand, this is it feels magical. Some tips. It really matters when you're dividing up code like this, whether the method or the field that you're working on is static or not. So you can, if you're lucky, your IDE will allow you to convert things from static to non-static and back. So in other words, a static thing can't have any instance data. It can only have data that's global across all instances-ish. Also, don't assume that you have to create the file first before moving code into it. You might find that if you say move a method to some file name that doesn't exist, it will go ahead and create it for you and add it to the solution and things like that. So those things I've just shown you lead up to another great Kent Beck quote. If you're ever stuck wondering what to clean up, move similar elements closer together and move different elements further apart. And it turns out that when you do that, you start to see patterns, you start to see groups of things, and from that, other improvements flow. Speaking of patterns, a pattern I found when I was working on this code was I kept creating new test source files. And so the way I did this initially was the IDE created the first one, and I couldn't find a thing that said create new test, so I copied test1.cs and renamed it to whatever my new test was and changed the class name. And at some point, it dawned on me to see how to use template files. And there's create a file template. So I go to tools, in JetBrains IDEs, you go tools, save file as template, but all good IDEs will have this kind of thing. It takes the current file and pastes it in, and it asks me for a name for the new file and a file name extension. And you can put variables in. So I said this $name thing that's highlighted, that will get replaced by the file name that I used to create the file. So I don't even have to name the file automatically. So let's use that. So I'll right click in the solution and say in the project and say add and select my XUnit JSON approvals test. It will ask me for a name. I'll call it demo file template. And it creates it. And you can see on line 5, I didn't have to put the name in. And a tactic that I use, and I encourage you to use yourself, is resist the temptation to forget to update something in the code. So I made my test name deliberately be something that wouldn't compile to avoid me having a load of tests that say, should remember to change this for a proper name. And should is a really good starting point for a test. It makes you think about expressing the behaviour, intended behaviour. Then I can update the contents and I've got my new test. Same thing applies with patterns within a file. So I found that I was creating new test cases quite often. So I did something similar, and you can say save as live template. And I said I would call it fact, F-A-C-T, as my reminder. And I've said that I want a placeholder there for the new test name. So let's carry on with that. I start typing fact, and as soon as I've typed all 4 characters, it pops up and says it's got a live template for that, and this is what it would look like. And if I think I had to hit tab or return or something, this pops up with the cursor perfectly placed for me to give it a sensible name. And I deliberately made it so the test would fail, assert 1 equals 2, so that if I forget to change the content, when I run the tests, I'll find out. So this is all about flow. It's about practicing. It's about letting the tools help you and practicing doing that. In a summary of the things that I've mentioned, I've sort of alluded to these along the way, but the benefits of making these small, safe, incremental changes, you'll be less tired at the end because much more you're thinking about intent rather than mechanical detail. You'll be confident that the behaviour is unchanged and that you've got snapshots saved, so if you have to put it down, you can come back to it. And I find invariably users get the features sooner. So my message to you is explore your IDEs, auto-fixes, refactoring, generation, practice refactoring difficult code. If you need an example, search for Kata, K-A-T-A. There are lots of practice exercises online, lots of them created by Emily Bache, who gave the keynote on Wednesday, and know how to use safe steps to transform the code. So that's how you get yourself into a state of flow. By investing time in improving your code, that time will pay off for your future self and your future colleagues in that you've improved the code and the code is easier to work on. So that time pays back in your future very effectively and to your well-being. But also by investing time in learning the tools and customizing them and learning the automation techniques, that will pay back for yourself. And there's this beautiful cycle of the code gets easier to work on and you get better at working on it. And that is the real superpower, not the refactoring per se, but the things that you build on top of it and how you improve your world and your capabilities. So thank you very much indeed for your attention. And we have plenty of time for questions. So I'm going to look over on my other screen and see what questions we've got so far. So you demonstrated the IDE change, remove unused parameter. Do you find that now you think about coding at a higher level of abstraction? I mean, you actually think in those higher level terms atomically instead of thinking of the large number of small edits that those terms imply? Yes, absolutely. And having seen some of the more powerful refactorings in C# IDEs, I very quickly came to understand what some former colleagues said about how much they enjoyed working in C#. I mean, I still like C++, but when I've got difficult refactorings to do in C++ and I've got fewer options and the IDEs are much slower to apply the changes because they've got more work to do, I'll think back fondly to preparing for this talk. Okay, I think I probably need to... Can somebody please mark talk things as applied as I've done them, because I'm not seeing the option. Okay, anonymous attendee, what would you tell people who argue that IDEs and their add-ons are too slow and that they are faster with a pure text editor? That's a difficult one, because people who say that genuinely mean it, and it's hard to know what to say to persuade them otherwise. Sometimes I found that pairing or ensemble programming can help. Just try it out and see. But when people's muscle memory is really good for the tools that they already use, it can be hard for them to see the value in other tools. Maybe once this video is published, you could ask them to have a look at this. I don't think you can force people to use other tools. And I think having a friendly team working environment is a really important part of work. So I certainly wouldn't try and persuade them to change. I think that's the best I can say about that. Unless I missed it, you didn't show the C++ version of approval tests. Can you say more about that? Yes, so approval tests is a general testing framework that was created by Llewellyn Falco. He's the coach that Emily mentioned visiting in her talk. And he invented this idea of capturing output and making it easy to reuse in tests, and he called it approval tests. And I was using for the first time the C# approval tests implementation called approvaltest.net. And there are implementations of this approval test approach in many different languages. I've made really good use of the Python one as well. And about 3 years ago, Llewellyn asked for help on the C++ version of approval test, which was very basic and didn't have the same functionality and didn't support any of the standard test frameworks in the way that the other language versions did. And I saw his tweet and offered to help. And so we have pair programmed on approvaltest.cpp for a long time now. And a lot of the credit for what I've learned and what I'm presenting in this talk really goes to Llewellyn. That it's, by pairing and ensemble programming, I've learned a lot from Llewellyn and from others. And you sort of go, wait, what? How did you do that? Oh, that's useful. I'll try that out. Thank you very much. If you want to know more about the C++ version of approval tests, if you Google my name on YouTube, you'll find, I'm not sure, half a dozen or more talks over different conferences and with different focuses. So last year I was speaking about using approval tests with the Qt graphical user interface library, for example. I'm always happy to answer questions about approval tests anytime. If you ever find that you've got code that you are stuck on and you can't see how to use it with approval tests, drop me a line. I can probably give you a very short answer and we can work together for a few hours or a day or two, if not. I've done that for a few audio organisations. It's non-obvious how to use approval tests with binary data, but it's very, very doable. And it composes really well to give you different ways of visualising data, visualising your outputs when tests fail, for example. Do you think there's any risk that too good refactoring tools encourage skim reading of code rather than taking the time to understand it before making the changes? That's interesting. By way of an initial answer to that, I'll say that, as I mentioned in the talk, I spent a lot of time experimenting with different starting points for refactoring the Sudoku code. And I didn't take all of them to completion. In theory, whichever way you start refactoring, the same concepts are in the code and you'll end up with a similar point at the end. But sometimes I kind of got into a dead end and then backed out and started again. And over time, very quickly, actually, I lost the ability to view the code with uninformed eyes. Because even just the first experiments, I learned very quickly that solved board thing was the right answer by seeing where it was used. And I know that it would have taken me a long time to work that out just by reading the code. So yes, as you're refactoring and as you're adding features, you'll still be reading the code and you'll still need to understand it. But each time you divide a large chunk of code up into a smaller one, you've got a smaller chunk of code to reason about, and you can reason about more confidently and more safely. So no, I don't think it loses the ability to read code. What they say in the refactoring book, there's a chapter that's written both by the author and by Kent Beck, and they refer at some point that as they've got older, they found that they're able to, as their brains have aged, I think is how they phrased it, they're able to hold less information and retain less information in there. And I've certainly found that's true for me. So yeah, 20 years ago, I had no problem reading dozens and dozens and dozens of lines of code and holding it in there. And as time has gone on and probably my interests have broadened as well, that's not the case. So I don't necessarily see that it's a good thing that you're spending time reading large amounts of difficult code and understanding it, when the whole point about these refactoring skills is you can apply these changes without understanding the code. That's maybe not something I really emphasised during the talk. You don't understand the code in order to make these changes. You make these changes in order to help you understand the code and make the code more understandable for other people. I hope that helps. Do current tools address refactorings that might want to change public APIs? In particular, reordering parameters would be bad for a public-facing function. There's a thing that I forgot to point out in one of my screenshots that if they're in C++ IDEs, I haven't seen them, that the modify parameters dialog had a little checkbox in there. It was the one that you could reorder parameters and delete them and add them. Had a little checkbox which had an option to create an overload and use that rather than replacing the previous method. So it's definitely possible to retain the previous implementation, the previous interface. And I didn't try that out, but from reading the description in the IDE, what it would do is that the new overload would call the old overload. So you haven't duplicated the code. I find that a lovely concept. I did find that if I had a method called play that took certain parameters, and then I typed my intent in the code, in the test, if I typed thing.play and passed in something different, it didn't offer me a quick fix at that point. It only told me I was passing in the wrong arguments. And so I got into a little pattern that if I wanted to create an overload by typing in what the new arguments were, I would give it temporarily a different name. I would call it play2 and pass in the new parameters. That would get created, and then I could very quickly automatically rename play2 to play, the original name that I wanted. And that's what I mean by experimenting. If it doesn't do what you want, see if you can work around it and just gently tease it, make it do what you need. The thing about knowing public, so carrying on with that same question about public APIs, I don't know the context of your work. I don't know the degree of safety that's appropriate for your work. Sometimes these IDEs make changes and they don't generate compiling code and you have to make something public. It's possible with, well, taking the C++ domain that I'm more familiar with, you might introduce a refactoring that perhaps creates an extra copy of an object or an extra assignment. And if your assignment operator or your copy constructor does something surprising and inconsistent, you might get some accidental change of behaviour. And it's not the job of these tools to understand that sort of thing. And there is a website whose name escapes me at the moment. And it's all about absolutely checking that at every single step there is guaranteed no change in the behaviour. So for a C#, C++ rename method, it might have 10 different steps along the way of making tiny, tiny changes, making sure everything is static first of all and things like that. So I will tweet the name of that later. Apologies that the name is escaping me at the moment. So you need to understand the context of the code you're working on and the environment that you're working on and what safety is needed. And you have to use the tools, all of your tools within those constraints. In C++, reordering automatically is hard because of overloads, but usually you can search the index for uses and then have an edit done consistently. Not sure I understand what's meant by the index of that. But then, or do like Michael Feathers and Martin Fowler describe with delegation. So yes, create the new method and have it call the old one. As there's time, I'll mention a technique that I really didn't think I was going to have time to mention. And that's called inlining. So you're probably familiar with taking some lines of code, one or more lines of code, and extracting them to a method. And you're probably familiar with taking an expression inside a line and extracting it to a variable. Those are common things to do. But lots of these refactorings have a reverse, and the inversion of the inverse of extracting is inlining. And so you might say you're extracting a method, and inside the code you want to extract, there's a new variable is created from some input, and you don't want to. You want to make it so that that new variable is passed in. What you can do is, I'm not explaining this very well. What you can do is you can extract variables, and move them around and make sure you're not changing any ordering that would change the behaviour. You've got a new variable, you extract the method, and now you've got two lines, one which said a equals 42, and the next line is call in a function, pass in a, and then you inline the 42, inline the a, and the variable disappears, and you've got one line which says call new function with the value 42. So extracting something to move you, to make your next step easier, and then inlining it is really powerful. Doing the same with functions is really powerful as well, or methods. If your IDE doesn't allow you to create and to move a method, say from one class to another or one file to another, and you do want to move it, you can create a call in the new location that's your new method that you want. It's a one-liner that calls the old one. And you can go through a series of steps to switch them round. So you can, if your old one is only going to be called in that one place, you can immediately inline it, and the IDE takes the code from the old location and puts it in the call site instead. And so if you can't directly move stuff around by inlining, extracting, you get a lot more power to move code around. Would you suggest that generalization, extracting interfaces using generics, is a good aspect of refactoring? What are some of the dangers? I'm not sure that I can. Oh, it's a terrible pun. I'm not sure I can give a general answer to that, which wasn't intended to be a pun. I think you have to decide what's appropriate for your context. Thinking about it now, none of the refactoring tools I've used in C++ have really been working on template code. That may say more about the fact that I haven't really worked on heavily templated code very much, rather than anything about the IDEs. I think you have to judge what's better in all refactoring and work out when to stop. Okay, thank you. There were some great questions. That looks like it's the end of the questions. I'll pause for a minute or two and see if anyone adds any more. But let me just reiterate, I would like to say a huge thank you to the conference, to Felix and others for the invitation to speak. It's been a great honour and a lot of fun, and I've really enjoyed giving the talk. I do hope that you get to try out some of what I've spoken about, and I'd love to hear how you get on. And drop me a line if you ever have any fun testing challenges, if you ever think code isn't testable and you'd like to try it out. So with that, I think I'll say thank you and farewell and hand over.